Welcome! Today we'll prove an interesting relationship involving the inverse sine function and its derivatives. Given y equals inverse sine of x, we need to prove that 1 minus x squared times y2 minus x times y1 equals 0. Let's solve this step by step. First, let's recall that y equals inverse sine of x. When we take the first derivative with respect to x, we get y1 equals 1 over the square root of 1 minus x squared. To simplify this expression, let's multiply both sides by the square root of 1 minus x squared. This gives us y1 times square root of 1 minus x squared equals 1. Now, let's square both sides of this equation. This gives us y1 squared times 1 minus x squared equals 1. Here's where it gets interesting. Let's take the derivative of both sides with respect to x. The right side becomes 0 since the derivative of 1 is 0. Using the product rule, we get 1 minus x squared times the derivative of y1 squared plus y1 squared times the derivative of 1 minus x squared equals 0. Let's simplify these derivatives. The derivative of y1 squared is 2y1 y2, and the derivative of 1 minus x squared is negative 2x. Now we can factor out 2y1 from the first term. Since y1 is not 0 except at specific points, we can conclude that 1 minus x squared times y2 minus x y1 equals 0, which is what we wanted to prove. This proof demonstrates how we can use calculus techniques like the product rule and chain rule to prove relationships involving derivatives. The key was starting with the known derivative of inverse sine and manipulating it algebraically.